Okay, welcome back. So today is on lesson 1B. So it's 1B in your textbook. And the difference between what we did the other day in lesson 1A and today is we are actually going to be doing some graphing now. So up until this point, when you see graphing, you think like you plug it in your calculator and you get a line. And that's not what we're going to do in stats right now. So what we're doing right now when we're graphing, especially categorical data, is that we are going to do this in terms of a bar graph. And so we're not going to plug it into the calculator yet. We're going to do this manually right now. But basically what this says is to better visualize the data, we are going to make various graphs from our data. So we want to visualize it to get a better idea of the distribution. And the distribution, and there's one of our vocabulary words, so distribution tells us what is happening over the course of all of the data. So these are some key things right here, and these things are key. It doesn't matter if it's categorical data or if it's quantitative data. Whenever you create a graph, any type of graph, dot graph, histogram, bar graph, you're going to need to do these things for all of these graphs. So the first thing that you're going to do is you're going to create a label. And so the label for each axis, actually, I'm going to step back even before you do that. Before you do that, you have to have a title. You have to have a title on your graph. That's going to be first. And then you're going to label each axis. And with this label, we're going to actually put tick marks on there. So we're going to have the title, and then we're going to put tick marks on the x-axis. We're going to put tick marks on the y-axis. And then we're going to label the x-axis. We're going to label the y-axis. And then we're going to label a key. And so a lot of times in stats, you're going to see title, tick, tick, label, label, label. And it's silly, but hopefully if you remember that, title, tick, tick, label, 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 it's going to help you. You're going to see we're going to model that right now. So label the axis. We're going to create these labels based on our categorical variable. The y-axis is going to be the counts or the percentages. We're going to scale it, and this is super important. The y-axis will always start at 0. I'm going to give you an example here at the end of the notes where we're not starting at 0, and you'll see how that is a bad graph. Each category has its own bar in a bar graph, and the bars don't touch in a bar graph. They will in a histogram, but not in a bar graph. They need to be equal width. Order is not important, so you can have tall graphs, short graphs, and then we're going to add a legend or a key. That's this third label that we have over here. And so let's just go do this. So we're going to use the data that we had in lesson 1 of our 4 political parties. So we had our 4 political parties, and if you want to flip back to your notes, we had the Federalist Party, and then we had the Democrat-Republican Party. We had just the Democratic Party. And then we had the Whig Party. So these were the data values that we had on that last chart. So the first thing that I'm going to do in a bar graph, and I don't have a ruler right now, but that's, you know what? Hold on. I have a postcard. I'm going to pretend like this is a ruler. So what I'm going to do, let me get my camera a little organized here, is I'm going to create this y-axis. And I'm going to create this x-axis right here. And what I want to label this as is the political parties for the first 10 presidents. Okay? And then down here, so there's my title. So my tick marks down here, I'm going to have one here that's going to be the Federalists. And then one here that's going to be the Democratic Republican, one here that's going to be the Democratic, and the last one here that's going to be the Whig Party. So I've ticked this off here. I've labeled it. Now I'm going to do it this way. And so if we look at our data, the biggest one that we have is 6. So I'm going to have 1, 2, 3, 4, 5, 6, 7. And this is the count, which we can say is the frequency. And I'm going to just label this. Okay, so here's what I have. I have my title, I've ticked off my 2 axes. I have my label, and I have over here the label that's going to be my legend. Okay? So if I look at this, the Federalist Party has 2. So I am going to take this to 2. This is my Federalist Party. That's a little wide. Hold on, let me fix this. Okay, and then my Democratic Republican Party, that's going to go up here to 4. And then this one is also 2. And this one is also 2. So this is what my bar graph would look like. So I can go in here and I can say the Federalist Party looks like this. The Democratic Republican Party's blank. This one looks like this. I'm going to have dots. Or I don't have to do this at all. I can leave these as just blank bars on my bar graph. Okay. Now, it's super easy to see that data from the table, but we can see it here. This is just a graphical representation. If you remember the other day, what we had was we had a table, and we said the table is tabular. And now we have a graph, and this is our graphical representation. So when we look at stuff in stats, we're going to see it tabular, and we're going to see it graphical. Okay? So, of the first 10 presidents, which political party was most affiliated with? Well, we look at our chart, we see which one is the highest one, and we would say the Democratic Republican. Which was the lowest and the least affiliated. And so what I'm going to say here is this is a tie between the other 3. So it's between the Federalists, the Democratic, and the Whig Party. And then it says here, what are the individuals in this data set and what are the variables in the data set? So the individuals are going to be our first 10 U.S. presidents. And the variables here are going to be the political party. Now, in the table, we had another variable, right? We had the variable which was birth state. But here, what are the variables of this data set? Well, the variables here are just the political parties. Okay? So this is one way that we can represent our data, categorical data, is with a bar graph. Okay? So if I flip this over, sometimes we see something that looks like this. And this is a multi-bar graph. And a multi-bar graph just means we've got more than one thing going on here. And so what happens is you'll see, that I don't have a title on this, so I'm going to add a title here. So it says, the Research Center asked a random sample of U.S. adults what they thought the best age for a U.S. president would be. The side-by-side bar graph summarizes the response of 18 to 29-year-olds and 60 to 69-year-olds. So my title here would be age of U.S. presidents. Okay. Now, what I'm going to do is you see that we have 2 categories here. The first one is 18 to 29-year-olds and then 60 to 69-year-olds. And my legend over here tells me what age group that they think would be the best for president. Now, I know that this is kind of hard to see, but I'm going to go ahead and write the age on top of this. So this is 30s. So 18 to 29-year-olds believe that 30 would be the best age. Now over here, there's not one. There's not a 30. So the next one would be 40. I'm going to write it up here so we can see it better. So this would be in their 40s. This would be in their 50s. This would be in their 60s and 70s. So here it would be 60 and it would be 70. Okay? So the question says, compare the distributions of best age for a president of the 2 groups. Okay, so that's what we're going to do. We're going to compare the 2. So when we do this compare, what we're looking for are keywords. And so the keywords that we need to find as we do this is more than, or less, or equal to, or actually some descriptor that's going to say that one is better than the other, right? And so what I would say, if I look at this data, I would say that both 18 to 29 and 60 to 69 agree that 50s are the best age for a U.S. president. Now, what is super important here is that as I've done this, I have used the context of the problem in my answer, okay? Both 18 to 29, 60 to 69 agree or are equal that the 50s are the best age for the U.S. president. So I pull my title back in, okay? Now, I can say some other things here. So 18 to 29, I'm going to say favors 30s more than 60 to 69. I can also say 60 to 69 prefers 60s over 18 to 29. So I'm using some keywords here, right? So more than, prefers, over. So you need to actually show some descriptive words that tell you when you're comparing that it's better or less than another, okay? The other thing, just that I'm going to note on this, is based on this being a percentage, we're going to say here that this is a relative frequency graph, right? Because this is percentage and not counts, it's relative frequency. And that's actually something else that I can add in here. I can say that approximately 47% of 18 to 29-year-olds versus, what is that, about 53% of 60 to 69-year-olds think the best age is in the 50s. Okay. Another way that we can look at categorical data are in pie charts. So this is another way. So we just did multigraphs and pie charts. Now this is a pie chart that is also showing relative frequency. It's in percentages, so this is also relative. And I think the thing about a pie chart is a pie chart just takes the data and makes these wedges. Now the key with a pie chart is that a pie chart must add up to 100%. So if I look at this graph, this adds up to 100%, this adds up to 100%, but when I compare the two, it's not going to be 100%. Down here, these have to add up to 100%. And then each wedge of the pie is a corresponding size to the chart. Okay? So categorical data is a lot easier to describe because we really just use bar graphs and pie charts. Okay, so now let's get into quantitative. And we have lots of different ways to look at quantitative variables. So graphing quantitative variables. So the first one that we're going to look at is a histogram. And a histogram is similar to a bar chart or a bar graph, except your bars are touching. Okay, so we have an exception on a histogram, and that's that our bars are touching. Okay, so lots of data here. So what all of this data is it shows the average income level for a household in each respective state. So there's a lot of data in here, and we're not going to take the time right now to tear this apart and really look at it. But what I did is I pulled all this together so that you can see how we would deal with something where we have a lot of data. So when we make a histogram, we have to put the data in bins. So if I look back here at my bar graph, I have these different bins, right? So I had federal, WIG, these different bins. Well, I'm going to do the same thing. The difference is now it's important that my bins are equally sized. Remember, the width of the bin is important. So what I'm going to do is I'm going to do this by hand so that I can show you how to do this. So the first thing that we want to do is we want to find the lowest income. So if I look up here on the graph, the lowest one is right here. It's Mississippi. And so the lowest income is $65,648.61. So that's the lowest household income. And then if I want to find the highest, that's right here, and that's Massachusetts, and that is $127,460.73. Okay, so for me to find the bin width, what I'm going to do is I'm going to round these numbers up because I don't want to deal with all these cents. So I'm going to round this one to, I mean, I guess technically I could round up, but I'm going to round down so that I can keep it in fives. So I'm going to round this to 65,000. I want it to be a little bit lower, right? And then this one, I'm going to round to 128,000. Okay, so I'm rounding this one down because it's going to be the lower level. Sorry about that. My dog was barking. So let me go back to this. The reason why I rounded down is because I have to make sure that it's below my lowest value. And the reason I rounded up is because I have to make sure it's taller than my biggest value, because I need to make sure I capitalize the lowest end and the highest end. Okay, so what I'm going to do to find my bin width is I'm just going to take the difference of this by the number of bins that I want to use. So I would have 128,000 minus 65,000. And I'm going to separate this by the number of bins. So here I've already done this for you, 1, 2, 3, 4, 5 bins. And when I put this in my calculator, what I get is 128, and I get 12,600. So these bin widths that are over here that I already have categorized out are based on this width of 12,600. So that's my lowest value, my highest value, and I just chose 5 bins. Okay, if I picked a different value, 6 bins, then these values would be a little bit different. So I've already gone and counted these up just to save time. And so these are my 5 bins right here. So these are my 5 bins. Okay, so when we make a histogram, we're going to make rectangles for each bin, and their height extends to the highest count. The bars must touch. Remember, that's what makes this one different. And then we're going to label each with the border value. Okay, now the border value is important because what this is this always says that the it goes to the lowest value. So if this is 77,600, it's not included here, but it is included here. Okay, so it's the lowest value that we have. Okay, so if I am going to create this histogram here, let me grab a piece of paper. So I have this histogram right here, and I'm going to use the data that I have to put this together. So I've already got my 2 axes. So remember, the first thing that I have to have on here is my my title. So remember, I have title, and then tick, tick, label, label, label. So that's what we're looking for here, okay? So my title is going to be, let's see exactly how I have this word, average income level. So average income level by state. Okay, now this side is going to be the count. So this is going to be my frequency of values. So if I looked at my numbers again, my highest one is 17. So that's my 17 count. So I'm going to look at this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to count by fives. And then this is going to be the income, and this is in thousands, is what it said on the other side. So the income in thousands. And what I'm going to do is I'm going to start here at 65. So because I'm not starting at 0, I'm going to make this little thing right here, and this tells me that this is not starting at 0. Now, this is important. This can only happen on an x-axis. My y-axis, this axis, always has to start at 0. Always, always. Okay, so my categories were 65, and then this one's going to be 77.6, and this next one's going to be 90.2, and this next one's going to be 102.8, and then I have 115.4, and then my last one here, which is 128. So I tried to make these ranges the same width, okay? If you're using a ruler, you can make them exactly. So the first count that I have here is 3. So 1, 2, 3. So this one's going to look like this. And then the next one that I have is 17. So this is my big one here. Oops. That didn't look very good. I'm going to fix that because that's going to irritate me. And I would tell you, if you want a ruler, come and see me and I will give you one, because I'm all down for the ruler. Okay, next one, 90 to 102.8. That was 15. So that's right here. Next one was 115. So it's 11. So that's over here. Now, what you notice when I do this is that my they don't have to be in order. Like I have a small one, and then I have a big one, and it's descending, and then this last one is 4, which would be right here. Okay, so what I want to do is I want to create this label, and my label over here, because I've got my labels on my axis, right? So I don't have a label for my legend, but what this is quantity of home prices. Okay, now here's something to be cautious of when you do a histogram. So this histogram looks pretty good, right? I've got this, it kind of tells me exactly that the majority of the country falls in this range right here. But if I had a histogram that looked like this, for example, let's just say we have something that looks like this. And I have nothing on this side and nothing on this side, and I have these two tall bars that are right in the middle. We categorize this as we say this is a skyscraper. I don't even know how to spell skyscraper. This is skyscraper graph, which means I've got two big graphs, and that really doesn't tell me much data. And so what I would need to do is break it out by more bins. So I would have more bins, and the bins would look something like this. And this is what I want, right? So this tells me that my bin size here is not wide enough, that I need to break it out. So if you have something that looks like this, this is not a good way to see data. We want to break this out. Okay? Now, you are probably never going to have to create one of these by hand. We are going to do all of this on a calculator. So this is the one histogram that you actually had to make, okay? Another way that we look at quantitative data, so here's another way that we look at quantitative data. It's called a stem and leaf plot. And usually we leave the leaf part off and we just say it's a stem plot. Okay, so what we're going to do is we're going to do a little experiment in class where we're going to find some pulse rates, and then we're going to use some data. But since we don't have a class right now, I'm just going to throw some random numbers up here, and then we're going to use these numbers. Okay, so I'm going to say 19, 20, 21, and if I triple this, 60 and 63. So the average of these, So 57 plus 60 plus 63 divided by 3. So the average of those is 60. Oh, duh. I could have probably done that on my own. Okay. So I've got this data, and you can, I'm going to pull this aside. You can, let me make up some data here. So let's just say female, female, male, female, female, and I'm going to give some average pulse rates, 63, 88, 46, 50, 68. Here, I'm just making some stuff up right now. We would have this as the class lab. Oh, it's a male. We got to go lower. 69, 61, male, female, female. That's probably enough. 70, 52, 90. Okay. So here's the data. So when we do a stem plot, I'll put that there so you can copy it. When we do a stem plot, we are going to create this little chart, and the way that this chart works is that we're going to have a stem, and the stem is for this, because these are all 2-digit numbers, the stem is going to be the tens place, and the leaf is going to be the ones place. So I'm going to put these in order. So if I look up here, my lowest value is 46. So the 4 goes on this side, and the 6 goes on this side. And that takes care of my 46. The next one that I'm going to use is 50. That's my next lowest one. So the 5 goes here, the 0 goes there. That would be 50. Then I also have a 52 up here. So this is the 5. So what I'm going to do is I'm going to put a 2, and this tells me 52. All right. And then I can move on. Next one I'm going to do is in the 60s. So I have a 61 right here. And then I have another 61. And then I have 63, 65, let's see, 66, 68, 69. All right. So as I do this, you'll see that all of these are lined up, and all of these are lined up, and we want to try to stack them as best as we can. Okay. So if I look at my 7s, I have a 70 and a 76. And then I go to my 80s, and it looks like I just have 188, and I had 190, okay? Now, if, let's just say, for example, I didn't have this 88, I wouldn't put 80, because if I did 80, that would tell me 80, okay? So I've lined these up. The leaves go in order from smallest to biggest, so I start with 46. My biggest one's 90. I'm going to line these up the best I can, which is what I tried to do, and then I'm going to put a label. So my label here is going to say 6 line 1. So that's what this is. 6 line 1 is 61 beats per minute. Okay, so this is my legend. So 6 line 1, which is what I have right here, is 61 beats per minute. Okay. Now, we can do a stem and leaf, and we can separate it out by guys and girls, okay? And that's what this bottom part is, separated out by guys and girls. So I'm going to put this in the middle here. So I'm going to have 4, 5, 6, 7, 8, 9, okay? And so my 46 was a guy, so I'm going to put my 6 over here. And I know it looks like 64, but bear with me, right? And then I'm going to go to my 50, which is a girl, so this is going to be my 0. My 52 is another girl, so she goes right here. My 61 was a guy, so he's over here. Now you see there's nothing here next to the 5 because there were no guys that were in the 50s. Okay? So my other 61, oh, they were both guys. So I have another 61 over here. And then, what else do I have? I have another guy. He's a 69. My 63 is a female, so 63. 65 was a female. 66 was a female. And 68 was a female. And then these, 0, 68, and 90. Those were all females, okay? Now, there's two things that I want to show you on this, okay? So I'm going to put the key. So my key over here, remember, I'm going to do 5-0, and this is 50 beats per minute. Now, I'm going to do a key over here, and this is why the key is so important. I'm going to do 6-4 is 46 beats per minute. So I write it exactly like I read it, 6 line 4. So 6 line 4 is 46 beats per minute because this number is 46, it's not 64, okay? So couple things. So as I have right here, don't forget a key. So super important. And remember the key has to have a unit. It doesn't say that, but I'm going to add that. Make sure you have a unit on there. And the other thing about a stem and leaf that's kind of cool is that this looks like a histogram. So if you look at our histogram, let me go back to our histogram. Here's what we have, right? And you can see where our biggest bar is. Well, we can do the same thing on a stem and leaf. So we can see, we never do this, but we can kind of see what our histogram looks like, okay? So the histogram, you're going to see here in a couple of days that the shape of the histogram is super, super important in stats, okay? Now, let's keep going here. Let's just say that we have a stem and leaf that is super, super long. So I'm going to make something up. I'm going to say 4, 4, and then 5, I don't know, 0, 0, 5, 6, 6, 7, 8, 9, 9. And then this is going to be 0, 0, 0, 2, 9, 8. Okay? So, oh, sorry about that. So lots of data points here. So if I have this, I am going to create a split stem and leaf. And this is what this looks like. So I'm going to have 4, 4, 5, 5, 6, 6. So this would be digits 0 to 4, and this would be digits 5 to 9. So what that looks like is this would have a 4 in here because I have 44. And then I would have nothing here. This one would be 0, 0. This one would still be long, 5, 6, 6, 7, 8, 9, 9. This one would be 0, 0, 0, 2. And this one would be, oh, these were backwards. These should be 8, and then this should be 9. 8, 9. Okay, so to kind of eliminate these super, super long ones, you can break it out if, and then you get a better representation of what that looks like. Okay, all right, I'm going to pause the video. And I want you to create a stem and leaf for this Unit 1 test data. Okay, so hopefully you saw that in the directions there it said create a split stem and leaf. So I have 6, 6, 7, 7, 8, 8, 9, 9. So I have this broken out. And you have to have a key. So here I have 6-2 is a test score of 62. Okay, and again, it doesn't matter which one you pick. All right, so the next type of graph that we have with quantitative data is a dot plot. So a dot plot, we've already used a dot plot. We did a dot plot when we did our Flint water stuff, or actually Parkinson's. I think Flint water, you've seen that too if you're up on your videos. And so what we're going to do here with this graph is that we're going to still use this test data. But now I'm going to take and I'm going to create a line graph right here. I'm going to create a line. And then on this line, I'm going to put my quiz data. So I'm going to use this data that I have up here. And so my data starts at 62. So I'm going to say 60, it goes to 96. So 60, 65, 70, 75, okay, so there's my line, and this is going to be test scores. Now, You'll notice when I do this, my big hash marks, like every 5 on here, are slightly larger. That is just something that I do to make the numbers easier for me to see. That is not a requirement. Okay, so now I'm going to take the data, and we've already got it in a stem and leaf right here, right? So it's way easier to see the data here for me than it is to see the data just listed like this. So I know I have a point at 62. So I'm going to go over here to 62, and I'm going to put a dot right here for 62. It's going to represent that first test. And then I have another test at 69. And then my next test is 74. And my next test is 75. And what you're going to notice is as I put these points, I've got them all kind of lined up about the same. Okay? And then 78, 79. Now here I have two 80s. So I'm going to stack those two 80s. And then I have an 82. I have two 84s. So I try to keep those even. And I have 1, 2, 3, 4, 5 88s. 1, 2, 3, 4, 5. And then I have two 90s, three 92s, 93, 94, and 96. So that's what my dot plot would look like. You've got this horizontal axis that's labeled. We don't have an axis that goes up. The tick marks here are all uniform. They're all the same. And then you just make a dot above the corresponding graph that you need. Okay? All right, let's keep going. Here's another dot plot. We're gonna get rid of this one. We just did one, so we're not gonna do another one. All right, so let's talk about misleading graphs. So beware of misleading graphs. This is what this says. So what I have here is when Apple first introduced the iMac in 1998, the company wanted to know whether this new computer was expanding its market share. Was the iMacs basically being bought by previous Macintosh owners? Was it being purchased by first-time computer buyers or previous PC users? To find out, Apple hired a firm to conduct a survey of 500 randomly selected iMac users. The firm categorized each customer as a new computer purchaser, previous PC owner, and previous Macintosh owner. And then we see the data here in this graph. So just looking at this, it's pretty obvious that what people were doing is they were converting from the iMac to the Macintosh. But let's look at the percentages here. So for me to find the percentage, so this count is technically a frequency, and this percentage is a relative frequency. All right, so if I look at that, I have 85 plus 60 plus 355. So this is 500, which is what it told me up here, 500 users. So I'm good. So if I want to find the percentage, I would have 55 divided by 500 times 100. So 17% were new, 12% were PC converters, and 55 divided by 500 is 71% were Apple transfers. Now, if I add these up, 71 plus 12 plus 17, this gives me 100%, which is what I need, okay? Now, sometimes when we're rounding, these numbers might be off a little bit, like 99 point something, but it needs to be close to 100. So what we know here is that 71% of iMac users converted from the Macintosh. So they were not really getting extra market share. Now, this is great. This is a table. This is fantastic. It gives us the data. We're able to answer a question. We're able to go in there and do a justify. And then here's the graph that they give. Okay? And what this graph shows is number of buyers. So this started at 0. And then it shows none, Windows users, and Macintosh users. Now here's the problem with this. If we look at this none, it's 17%, right? So we say that this is 17%. So if I take 71 and, 71, and I divide it by 17, that means that I need 4 and a little tiny bit more, so 4.1 of these guys should fit inside this if I'm doing a pictograph. So if I look at the size of this graph, well, there's 1, and there's 2, and there's 3. There are way more than 4 of these images in here to represent 17%, right? Way more. So pictographs do an awful job of demonstrating. We're looking at area here. And so it's super misleading. 71% is a lot more, and this represents a lot more, but when you're looking at the area of this versus this, it doesn't even make sense. So how is this graph misleading? So the area of none is not equally represented in the Macintosh picture. Okay, so whenever you see a pictograph, definitely don't look at the picture, go look at the table. The other thing, I don't have a graph here, but the other thing that happens often with a pictograph is that we start this value right here, doesn't start at 0. So if this started at, let's just say 60, and then we went up from 60 because that was our lowest value here is 60, then what happens is that our Windows user right here, he's not even represented. And so it's always important, and we've said this before, is that on the y-axis of any graph, it must start at 0. And that is only the y-axis. If you remember, what I did here is I said, you know, my this didn't start at 0, but this y-axis did start at 0. Okay, so make sure that when you're looking at all of your graphs, that your graph always starts at 0, has to start at 0. Okay, sorry, I know this was a long one with some interruptions, but I appreciate your patience.